I've started recording now. So, in the world, there's something called a three-body problem. And I'm going to put it very, very, very simply. Okay? And I'm going to show you it, and you'll see what I mean. If I've got one body, this can be an atom, this can be a planet, this can be a star. And if I've got another one, so I've got two, we can predict where they're going to be. All right? Especially the same mass, if they're about the same size, we can predict where they're going to be in 1,000 years, in a million years. That's relatively easy to do. Bringing a third body, we cannot. All right? So we're going to have a look at very, very small. So I'm going to start off with looking at atoms and how stars are born. We're going to have a look at how these particles interact, and these are atoms of hydrogen. And then we're going to look at stars and planets. Now, the problem is I can stand here or sit here and talk to you and be a really, really boring person because all you're doing is listening to what I'm saying. But we're not going to do that. There are, on your bit paper, two links, the short link and a long link. Your bit paper, your Miro board. Doesn't matter which one, it's the same thing. This is the Colorado University Simulator. All right? As per usual, there's no need to log on. Right? And I really believe that you shouldn't be really sharing your details online. So having access to things that don't require a log on is really important. When you click on it, actually, I'm going to click on it and I'm going to there. So when you hover over it, it goes here, and I'm going to click on it. And it comes to this place, my solar system, intro and lab. I'm not going to intro, I'm just jumping straight to the lab. All right. Now, as I jump straight to the lab, you can see two things. And we have the sun and the planet. Now, I'm going to clear that. We are going to play with these at some point, but I'm going to clear this. I'm actually going to go to the right-hand side. You can pick all these different things. And you can go to custom. I'm actually going to clear everything. Actually, no, I'm not going to clear everything. I'm going to do the easy way. So what I'm going to do is I'm not going to look at stars and planets first. I'm going to look at atoms and particles. I'm particularly going to look at hydrogen. I'm going to click on this one. Now, this arrow here represents velocity. Velocity is speed in a direction. Well, it's an arrow, so we have direction. The bigger it is, the bigger the velocity. So, do you know what? I'm just going to so down here, you can pick how many bodies you've got. And I'm just going to get rid of one of the bodies. Okay? Now, if I click on the velocity and increase it and press play, oh, sorry, the play button's over here. It'll just move in that direction, and I've got it on normal, it'll keep going. If I stop and move back, make my velocity bigger, it'll shoot off faster. Okay. So what I'm going to do is I want to make it very, very small, and I just pull that across. And I don't want it to move at all. In terms of, I'm not going to give it any velocity to start with. I'm going to add another body. I'm not going to give it any velocity to start with. Now, if you picture this, these are two atoms in space with nothing around them, and they're not moving. And this is the idea of what happens if I press play. Well, if you press play, there's a force between anything that has matter, anything that has mass, and it's gravity. And if I press play, I'm actually going to have to go on fast. Nothing really happens. But if you watch very carefully as the time moves forward, they'll start moving slowly. Actually, they'll start moving very slowly. I might put the gap just a little bit too big. I'm just going to stop. I'm just going to move them just a little bit closer to each other. And we'll drop the velocity to zero. So gravity is a force of attraction. And when I press play, I've put it on fast. These are the years passing by. They will slowly be attracted to each other by gravity. This is what happens in a nebula, in a cloud of glass. And you can see that they're slowly starting to move. Okay? Now, they'll move, and then they will crash into each other. All right? Now, so, oops, I don't want that one. Oops, I don't want that one. Where's it gone? Oh, there it is. That's the one. and it crashed and it smacked into each other. So I can go here, press back, and start again. This time, I'm going to make the move slightly downwards. So that was. I'm just going to give that a little bit of velocity. And I might actually give it that much. I'm not sure if that's enough, but that's a bit too fast actually. So I'm going to back up, give it a little bit less. And what I'm trying to do is make it miss. I'm going to give this one a little bit of velocity. Um, Shoot them towards each other. Hopefully they just miss. Yeah, they do. They're a bit too fast. I want them to get into some kind of relationship. What I mean by that is they should pull each other slightly. That's still a bit too fast. Okay, so they're really predictable. You know which way they're going to go. This is a bog standard two-body problem. You've got two things, two bodies. Now I'm going to have a third body. I'm going to bring it down here, pull its velocity down, right? So I might even make it go this way slightly. I don't know. I'm hoping. Oh well, they crashed. Now watch. They kind of interact with each other, and as we change certain values, there's a really interesting one that I got that I should have really um, saved. Now, maybe we should be a bit closer to each other. So you play with the three body problem, and you'll get to a point where they just don't want to behave, and they kind of blow up. Okay, so that's one thing you want to have a look at, and to make it into the bigger world, that's actually what happens in stars. They crash into each other, and that releases heat, and that's how stars are born. So on custom, we can go to sun and planet, and we can do some really interesting things. That's a sun and planet, and if you press play, you have a planet here orbiting the star. This is a two-body system, which means I know exactly where everything is going to be at any point in the next million years. We know where the Earth and the Sun is going to be in a million years. This is a two-body problem. So now I start being interested. I think, do you know, I'm going to add something. I've added something here. I'm actually going to give it some mass. I've added a comet. I might reduce its mass to about 5. Okay, and press play. So now I've got a comet. Now hopefully you'll see the orbits are predictable. The sun has now been shifted, and things are just oh, I nearly hit the sun. Oh, I did. Okay, so this is a three-body problem. They don't behave properly. And if I make its velocity faster, so this is the planet, this is the sun. I'm going to kind of pull its velocity to 0. I play. So now we've got three bodies, and they're just going to be strange. I'm going to zoom out. You can zoom out using that. It's so, what is beautiful, but it's so unpredictable. So it kind of makes a semi-predictable shape, but the longer you leave it, the less predictable it is. It's not like a planet orbiting the sun. Now, the promise is brilliant. It's virtually impossible to calculate what three bodies are going to be in a given time. You can only do it second by second. So I'm just gonna change them. Oh no! All right, so let's if the velocity of the planet's too slow, it crashes in. So, right, the velocity's back. Right, way there we go. That was interesting. Oh, this is a three-body problem, and this is a lovely simulation where you can change things. You can look at things, and if I just reset this to sun and planet, and say, right, you know what? I want to have a moon in this. So how do I put a moon in? Well, I increase the number of bodies, and I think, do you know what? That's like a moon. Let's. Oh, well, that wasn't very good, was it? I destroyed my moon. So I'm put my moon here. I don't know where to put the velocity. Should I put the velocity that way? I don't know. Will that work? And it's not that easy because the moon keeps crashing into the Earth. Let's see if we can make it even more powerful. in terms of higher velocity. Not powerful. Oh, it's too far. It shot off. My moon shot off. All right. So I have to make its velocity slower. But if I make it go slower, oh, there we go. Oh, now it kind of bent. It was bent by the Earth. Now it's turned into a. Oh no, gone. Okay. So it's really not that easy. Oh, oh, I've got a moon. I've got a moon. I've got a moon. And if you see, it makes a look. However, now we've got a problem. Will the moon affect your orbit? The Oh, I think it's going to work. Oh, it had a funny one there. But I've now managed to put a moon around a planet orbiting a star. What I can do now, see if I can add a comet and see what effect that will have. Okay. Here's a comment, and I'm going to make my comet. I don't know. Do you know what? I'm just going to give it a bit of velocity and see if I can make it swinging towards the sun and not blow up. There's my comet. Whoa! Whoa. Oh, and it's the other thing you can do. If you pause it and I reset it, um, there's my moon, there's my Earth, there's my comet. It's going to, I can increase its mass. So my comet, I can make it heavier, give it more mass. Say heavier, that's a bit of a more mass. I'm going to go to I'm going to go to about 5. Oh, I just wiped out the moon and the Earth. Oh my God, and the Earth has lost orbit and is leaving the sun. All right, so this is brilliant. You can change the mass of your bodies. You can change the velocity. You can really have a look. Oh my God, it's 11 minutes. That's very bad of me taking up your time.